Homework out. Let's open to page 249. You did the review 1 through 12 and the practice number 8. Some of the review, the first 6, are stuff you'll see on the exam coming up at the end of this week. This is lesson 129. The exam will be lesson 133 for those watching on YouTube. Friday, for you guys. Not for you, you're getting going. But Friday, we will take our exam in here over sections 4.1 to 5.4, basically chapters 4 and 5. So that's what's coming up. Now, the last few, number 7 through 12, that's stuff that won't directly be on the exam, but you have a good review for us as well. So page 249 in your textbooks, you have the review 1 through 12 and then practice number 8. So there's the 8, 1 through 12. Quickly turning there, please. What happened?
I didn't have study hall on Friday. We left 15 minutes after I got home.
All right, do you have a homework pass?
Yes, I do.
Okay, let's get that out then.
Yeah. And then I forgot half the stuff.
Well, I will refresh your memory on the half that you didn't forget. And that's why we do the homework, that's why we review. And so it'll be good. Number 1, all you're supposed to do is find the slope of the line passing through the points. To find a slope, we need the slope formula. What is the slope formula, Maddie? Good, m equals y2 minus y1 over x2 minus x1. So we could pick either y value to start out with, Maddie, minus the other y value, good, over, we've got to go with the x that matches the 8, minus, and of course anytime we see minus in negative class, we're going to make that positive, and so really straightforward, Maddie, we get a slope of 3 over 5, or 3/5. So I'm going to get a slope of 3/5. All right, what is slope, by the way, class? It's what over what? Rise over run. So this line rises 3 for every 5 that it runs forward. Same thing on number 2. Finding the slope, y2 minus y1 over x2 minus x1. What'd you get, Kendall?
8, 9.
Genesis? Should have been 2/3. So I would have started maybe with the y value of 4. Minus the negative 2 over the 10 that goes with the 4 minus the 1. That'll give us 6/9. Do you say 8/9?
Yeah.
I wonder if you multiplied somehow. I don't know.
I know what I did. I had the 10 with the 2 and then the 4 with the 1. So.
And a 4 and a 1 gave you a 9?
Yeah.
Okay. For redemption, number 3, you're supposed to find the midpoint. What's the formula for midpoint, Kendall?
M.
Capital M this time.
Equals parentheses x1 plus x2 over 2 y plus y0 over 2.
There we go. Add the x's divided by 2, add the y's divided by 2. Basically averaging the endpoints to get the midpoint. Kendall, when you averaged the x's, the 9 and the 13, it gave you
4.
Well, that's if you subtract them. You're adding and dividing by 2. So if you add 9 and 13,
22.
divided by 2,
11.
11. And then we also need to average the y values. That's, negative 1 and 0 is just divided by 2.
Negative.
And that should have been our midpoint there for number 3, 11, negative a half. What about number 4? What do we get for the midpoint, Michael?
3/8.
3/8 when we solve that. How many good to go on 3 and 4? All right, any questions 3 or 4? Obviously you kind of went over it now, but any questions still? All right, number 5 and number 6, you're supposed to find slope-intercept form of a line given the point and the slope. What is slope-intercept form of a line, Audrey?
Y equals mx plus b.
Good, where the m class is our slope and the b is the... So to know slope-intercept form, what 2 things do I have to know, class? Slope and y-intercept. Well, they gave us the slope here. They told us the slope is negative 1/3 on number 5, but they didn't give us the y-intercept. We had to find that. What do we do, Brandon?
You plug in the y and x's into the equation. So I put negative, 7 equals negative 1/3 times 3 plus b.
There we go. Start out by plugging the m where the m goes, where the slope goes, and then the x and the y would be the abscissa and ordinate of any point that happens to be in the line. Well, of course, 3,7 they told us is a point in the line. We can plug that in. And then, of course, we can cancel here, Brandon. There we go. So once we know that b is 8 and m is a third, well, those are the two things I needed to know, the m and the b. What is the equation then, Abby?
The equation is y equals negative 1/3 x plus 8.
And there we go. How many had this for number 5? Are any questions on 5? I think this is where you ran. Now, was this a I ran out of time, hence homework pass, or was this a I forgot what to do?
I forgot what to do.
Let's go ahead and have you, now that you've seen it, do you feel like you remember it now?
Sure.
All right, let's do number 6 together then. Walk me through. We want the equation for number 6.
Y equals 5x plus b.
There we go. And so to figure out what exactly the b is,
Negative 3 equals 5 times negative 2 plus b. 7 equals b.
good, this is a negative 10, move it over as a positive 10, 7 equals b. So therefore,
Y equals 5x plus 7.
good, y equals 5x plus 7 should have been our answer on 6. How many had that for 6? All right, and you're good to go now?
Yep.
Excellent. Number 7 through 12. So by the way, all of that stuff you'll see on the exam. Last call, any questions on exam-y stuff? We're going to review it again probably Wednesday, maybe Thursday. I think this stuff is supposed to be reviewed on Wednesday. Questions on this? Now the rest of this review is just for the sake of review stuff you'll see again in future years. Probably see some of this on the final exam as a result, but that's not, till lesson 170 something. Number 7, if we're factoring, we got to start by identifying what is that thing. What special factoring case do we have in 7 class? Difference of squares, and difference of squares factors into Genesis. Sum of difference, so the x squared minus 144 should factor into. Very good. And that's all there was to it. How many had that? We remember difference of squares. All right, good. Number 8, someone besides Genesis, what is this special case? Sum of cubes. Okay, a sum of cubes. We use the term sum for the addition there. How does the sum of cubes factor, Audrey?
Into monomial times monomial.
Will someone help?
For cubes?
Sum of cubes. Binomial times a trinomial class. How do we factor the sum or difference by the way, sum or difference of cubes factors into class A. Binomial times a trinomial. Again, sum or difference of cubes? All right, so here, one of the keys, remember, we said was you want to rewrite a number as a cube. And of course, 27, back to Audrey, is?
3.
Cube. There we go, 3 cubed. So this helps you see the sum of cubes. And so with the sum of cubes, we said it factors into a binomial times a trinomial. The binomial is really, really easy. It's literally, you're looking at it, class. X plus 3. You just ignore the cubes and you've got the binomial. But for the trinomial, remember, class, we said we're going to start with the x to 1 power less. So therefore, class, x squared. Then it's going to descend in the next term down to n, x to the first, and then finally the next term, the x is gone. Meanwhile, the 3 is going to start out gone. Then it'll grow to become 3 to the first, which is 3. And then it'll grow again to 3 squared, which is 9. If there's a plus, you keep the plus. If it's a minus, you keep the minus. If there's a plus, though, what about the signs here, class? Alternate, positive, negative, positive. This is what we should have had for number 8. Did anyone happen to have that, just couldn't articulate it? Okay, and then Genesis was ruled out. I didn't let her answer. Questions on this? All right, those who had forgotten, do you remember it now? All right. Number 9. What is that case? Difference of same odd powers. So kind of like the last case, we want to rewrite the 1 as something to this power. Well, what is 1, class? 1 to the 5th. And just as this was binomial trinomial, this is going to be binomial times 5-term polynomial. Kendall, take a shot at it. First the binomial, it's literally staring at you.
X minus 1.
Okay, and now for the polynomial.
X to the 4th, x cubed, x squared, x gone.
All right, and then the 1.
1.
Gone.
Gone. 1. 1.
1 squared, which is 1.
1.
1 cubed, which is 1.
And 1.
1 to the 4th, which is 1. What about my signs, class?
Positive.
positive.
This time all positives because the negative had already been used. Did anyone happen to have this on number 9? Okay, several of you did. Excellent. Okay, questions on this? Questions on this? Michael, again, use the homework pass. That's fine, so you're good, but does it make sense?
Yeah.
All right, we remember it coming back to us. Number 10, this one's sneaky. What is this thing, class?
Politician.
It's a sum of the same even powers. And all even powers are squares. Okay, that's something we should have memorized, class. All even powers are squares. So therefore, if it's a sum of even powers, it is a sum of squares, and a sum of squares is prime. It does not factor. Good job reading the P on my lips, though, by the way. Sum of squares is prime. I didn't mean to do that. I put my mouth. Sum of squares is prime. So you can't factor number 10. We're done. Just say prime and move on. Anyone catch that it was prime? Michael's like, I didn't factor. I knew better. All right, questions? Number 11. X to the 6th minus 64. Well, what is this, class? Difference of even power, so difference of squares. Difference of squares factors into Maddie? Sum and difference. So we just factor in a sum and difference like we would the first sum and difference, right? It just happens to be yeah, it just happens to be x cubed plus 8, x cubed minus 8. Now, the unfortunate thing about this is, look at the x cubed plus 8. Class, what is that? A sum of same amount of powers, or more specifically, sum of cubes. And what about the x cubed minus 8? Difference of cubes. So that means the sum of cubes, class, this factors into a binomial trinomial. This factors into a and with the 8s, rather than thinking 8, it would be good to think what here, class? 2 cubed. That helps us to see the binomials a little better. Now, technically, best order would be binomials together, then the trinomials together. This might make it a little easier, though. What does the binomial trinomial factor into right here, Michael?
X plus 2. X squared plus 2x plus 4.
Close. Question.
Minus 2x.
Good. Alternate the signs, so we got the minus. And then what about the x cubed minus 2 cubed, or the x cubed minus 8? Brandon?
X minus 2. X squared. And x. And then 2x. And positive.
There we go. And again, best case scenario, you slide that x minus 2 up a little further. Did anyone take it all the way down? You factored it completely. Okay, Abby, do the questions from the rest of you. How many at least got the x cubed plus 8, x cubed minus 8? All right, does it make sense now? We want to continue factoring as much as we possibly can. Questions on that? All right, let's take a look at the last one now. Number 12, what is that thing? Genesis? Perfect square trinomial. Perfect square trinomial factors into, class, binomial squared. We've done that a little more recently because of our other solving techniques, right? Backwards FOILs, one we're still really good with. Perfect square trinomial should be one we're still pretty good with. What was your answer?
I got confused in this one too, and I just realized it's
Oh, okay, so what should we have put, right? We got the 9x squared plus the 12xy plus the 4y squared. Let's put it into the binomial squared.
3x plus 2y.
And then we check, if we multiply and double, would it give me a 12xy? It would indeed. How many had that for number 12? All right, questions on the factoring. Been a little while. Good review for us. Questions? Good news, not on the exam. All right, so not on this one anyway. Final, yes, not on this one. Let's take a look at practice number 8, just above the review. And systems of 3 unknowns. What's kind of the key to solving a system of 3 unknowns? Abby?
Making a new system out of them.
Make a new system that has just
2.
unknowns. We know what to do with 2 unknowns. It's the 3 unknowns that causes us problems, right? And so really we want to start off, after we've written it down, we want to pick What do we want to do now once we've got our system of 3 unknowns?
Get rid of the z.
Good, get rid of a letter, right? And if you want to get rid of the z, that's fine. You want to get rid of something else, but pick a letter that you're going to get rid of, but you're going to have to get rid of it how many times, class? Twice. So whatever you pick to get rid of, you're going to have to do it twice. How many, Abby said z, how many also were thinking z here? All right, what did you get rid of?
Well, I got rid of z, but it didn't work for me, so I tried x, and I still wasn't.
All right, so let's see if we can figure out what we're doing here.
Copy it down correctly.
She copied off of Brandon's, is that what she said?
I actually checked to make sure I copied it correctly.
All right, so if we're going to knock out the z, all right, I would think starting with the first 2 equations would be good, right? But we'd have to multiply the top by a 3. Okay, so let's put a 3 through the top and let's see what we come up with.
6x minus 7 plus 3z equals 3.
And of course, we'll keep our second equation, the negative 4x positive 7y negative 3z equals negative 7. Okay, Genesis, I assume that's what you did first also.
Yes.
All right, what happened when you did that? Talk me through what we should have now.
Cancel the z's. 2x minus 2y equals negative 6.
Yeah, negative 6. Oh, you still had a 1. That right there is your problem. All right, should have been a 3, so should have given us negative 4. And by the way, as I see this thoughts class, I can knock a 2 out of everything to make it. And that's a very happy equation. We need one more happy equation. Then we need to knock out the z again. And Michael, which 2 equations do we want to put together to knock out the z a second time?
The bottom, hold up. The bottom, no. The first and the third.
First and last, okay? So let's put first and last together here. Though, we'll have to multiply what through the top?
5.
5 through the top, and then we might change the signs here. Let's just get the 5 through the top for now and see what we want to do as far as changing signs. Tell me what to write.
10x minus 15y plus 5z equals 5.
And for now, I'm going to keep 5x minus 6y plus 5z equals 7. Where do we want the negative?
In the bottom.
Yeah, let's go ahead and put it through the bottom. And that's going to get us what?
5x minus 9y equals negative 2.
All right, unfortunately, nothing we can take out. So it's a happy equation, but it's not as happy as the last one. And so we take these two, and as Abby said, we make the whole new system. The x minus y equals negative 2. The 5x minus 9y equals also negative 2. And then we get to pick how we want to solve this system. Maddie, substitution or addition? All right, so you rearranged the top equation, I believe, to say. Good, or if we wanted to, y minus 2, but negative 2 plus y works as well. We'll take this y minus 2 or negative 2 plus y. Make sure you plug it in for the x, since that's what we said it was equal to get. We'll combine the y's together, Kendall, to get. And at the same time, be careful, this negative 10 class moves over as a positive 10 to get 8, so that y, Kendall, equals. Now this is interesting, because if we plug in the negative 2 here, we end up getting x is equal to. Okay, Abby. Negative 4. And my brain at first was seeing the negative 2. I'm like, oh, those negative 2s are going to cancel and give you 0. It was minus and negative, so I'm glad I plugged it in here so I didn't say 0. Negative 4. There's x, there's y. But class, I do still need to find z. So Audrey?
You can plug it in the top equation.
Wherever the z is easiest, which is the top. And so we said y is a negative 2 and x a negative 4. Okay, so right here,
6.
but right here,
Negative 8.
negative 8 and 6.
Negative
Move the negative 2 over.
2. 3.
Z equals 3. So our answer should be what, class? Negative 4, negative 2, 3 should be our answer here. Double checking, and yes. How many had this? For number 8. All right, and again, you didn't do it. You feel like you're good on these?
Yep.
Okay, Maddie and Genesis. Genesis, we found out right off the bat where your problem was. Maddie, questions, comments? right here. Okay, so you got the -4 and the -2, just for whatever reason when you plugged it back in, math error somewhere. Okay, all right, questions? All right. The next thing I want to talk to you about, our last thing, as we wrap up this chapter, we've been spending a long time on systems of equations here. Last thing I want to talk about are systems involving quadratics. But before we do that, I want to just kind of recap with you quadratic equations. We said a quadratic function class will be graphed as a parabola. A quadratic function will be graphed as a parabola. And the key to a function, remember, and let me zoom out just a little bit here. Make sure that shows up. There we go. All right, a quadratic function, and YouTube, I'm sorry, I know a white background is absolutely horrible to see on video, but maybe you can see this. I didn't have time to try to change the whole picture around. Quadratic function, remember, replaces y with f of x, but it passes the vertical line test. This is your typical quadratic function. Passes vertical line test, you've got the x squared. We don't have an x to the first power in there, so it's an incomplete quadratic function, if you will. The graph is a parabola. If it were not a function, instead of the x being squared, you see that the y is squared. This is still a quadratic, it's just not a quadratic function. It's a quadratic equation. Still a parabola, now turned sideways. X is squared, y is not, it goes up. Y is squared, x is not, it goes to the side. Make sense? But what if you squared them both and added them together? Well, you could get a perfect circle. X squared plus y squared equals 16. Notice a radius of 4, by the way. You see the 16? 4 squared, radius squared, and the center here at 0, 0. But when I change it and make it a 4y squared, I change the numbers. I put a number, a coefficient on the y, and it squished the y as a result. If I put the x on the 4 on the x squared, it would have squished the x instead. It would have been a tall ellipse, oval-looking thing. So that's also a quadratic. So circles, ellipses, those are also quadratic equations. Not functions, but equations. Again, these would fail the vertical line test, right? A hyperbola doesn't have a plus, it has a minus between them. So this, you see these two, almost looks like a couple of parabolas facing away from each other. They're not quite parabolic, but they're close. Probably the best way to think of it. And this is something we have seen, right? Where we had a rational function where we said f of x is equal to, for instance, 1 over x, right? Well, let's suppose it was a 4 over x. And let's suppose instead of writing f of x, we said y equals 4 over x. Well, if you cross multiply xy equals 4, this is how we would have looked at it as a function before. That's what it looks like as a graph. Well, because of the x to the first, y to the first, what's the total power here? 2. This is second degree. This is still quadratic, even though neither is squared. Because they're together as a term, it combined is squared. We still get another hyperbola, but it's tilted, right? It's not this hyperbola, right, where you see them sideways. They're actually slightly diagonal of each other. Does that make sense? Well, you can imagine how all these different shapes could interact potentially if we were to graph them, right? Or even if we just went boring and graphed with a line. Well, rather than taking time to try to graph all of these things, because that's just absurd, right? We don't have time to learn how to graph all these different shapes. We can use math to solve systems involving quadratics. That's the next thing in your notes, solving systems involving quadratics. I don't know if you've written that heading yet or not. I think I may have given it to you already. Solving systems involving quadratics. The big thing you need to know is that you will often use substitution. You will often use substitution. You will often use substitution, and you'll see why in just a moment. Systems of equations involving quadratics. Copy this system on your paper if you would, please. X plus y equals 5. That's a good linear equation, right? Straight line, we like those. Those are happy. And then x squared plus 2y squared equals 18. I see squares, quadratic, not happy. By the way, from the quick rundown we just did, what would that be? The oval thingy, yeah, the oval thingy, because they're squared and added like a circle, but there's a number in front of one of them, so it squishes it in the y. So a little bit of a flatter oval, not too terribly flat. So basically we've got a line and an oval. How many times would a line cross an oval or intersect an oval? twice or possibly once, not infinite, or none, right? Does this sound, by the way, like locus problems, those who had geometry last year? Yeah, could get 0 points, could get 1 point, could get 2 points. Well, let's see what we're going to get. You realize I don't have like terms that line up. So I'm going to have to solve this thing by substitution. What we want to do is start by substituting the lower power equation. We don't want to have to substitute an x squared. So let's take this, and I can either get x by itself or y by itself. Strategy tip. If I get x by itself, I'm going to have to take whatever I get and square it, right? But if I get y by itself, I'm going to take whatever I get, square it, and then distribute it too. I'm lazy, which am I going to do? Get the x by itself. So let's say that x is equal, class, to 5 minus y. And let's take the 5 minus y and let's plug it right in here where it says x. So it's not x squared anymore as you're doing this with me. It's 5 minus y squared plus 2y squared equals 18. Not x squared, but 5 minus y squared. And guess what we're going to have to do with the binomial? Square it. So 3 things, class? Yeah. All right, so we square the first square, the last multiply and double, yeah. And what do we get when we square the first square, the last multiply and double, yeah? Brandon?
25 negative 10y positive y squared.
Good. 25 negative 10y positive y squared plus the 2y squared is equal to 18. Now we've got to combine the y squares together, class. 3y squared. I'm going to keep the lonely negative 10y who has no friends. And because it's a quadratic, I want to set it equal to 0. And so I'm going to bring the 18 over as a negative 18 to get 7 equals 0. And now we've got our quadratic equation, right? Set equal to 0 and factor. Or if factoring doesn't work, we could complete the square. Or if that doesn't work, formula. Let's hope factoring works. Let's see what happens here. The 3y squared has to be, class, 3y and 1y, or just y, right? Positive sign tells me the signs have to be both the same, in this case both negatives. And the only way to split up a 7, 1 and 7 or 7 and 1, right? But it's those two numbers. Well, if I put a 7 here, I'm already getting a 21. That's a bad feeling. So let's do 7 and 1. Does that add or intercheck? Yes. So what two answers do I get for y? 1 and 7/3. Now realize, class, these are two different y values. Remember, we're talking about a line and an oval. A line could cross an oval twice. When it crosses twice, 2 different points, right? And on these 2 points, one of them has a y value of 1, one of them has a y value of 7/3. Does that make sense? 2 different y values, 2 different ordinates because 2 different points of intersection. How do I figure out the abscissas or the x values of these points? Go back here, just like we normally would in substitution. But instead of only one number that we plug back in, we've got 2 numbers. Well, let's go with the easy one first. Plug in the 1, class, we get 4. Calculators, if you need them, we plug in the 7/3, and what do we get?
2 and 2/3.
2 and 2/3, or we could say 8/3. This point, if you were graphing, it would be better read 2 and 2/3, 2 and 1/3. But since I'm not graphing it, this looks awfully easy to me. Though if I were to graph it, it would look like this. And again, I don't know how well this is showing up for you on YouTube, but notice we've got the point 4, 1, and then right here we've got the point 2 1/3, 2 and 2/3, 2 and 1/3. And there's my 2 points if you were to actually take the time to graph this, which I just made the graphing calculator do it for me. Questions on this? What?
Where the graph? What?
It's a computer-based graphing calculator. So I type it into the computer-based, internet-based graphing calculator and graphs it. Questions on this? All right. Go and write this next one down if you would, please. X squared plus 2y equals 5. X squared plus 2y equals 5. And 2y equals x minus 7. What is that first equation? What shape? What? The first one's an oval? No. There was only one of the letters is squared. It's going to be a parabola, right? It's going to be a parabola. And by the way, it's going to be a function because only the x is squared, not the y. Okay, so this is basically we could, in fact, if we replace y with f of x and got it all by itself, we could actually figure out how to graph that. I just don't want to. What about the bottom equation, class? Straight line, right? It's linear. So we have a quadratic, more specifically a parabolic quadratic, and we have a straight line, a linear equation. And again, we don't want to solve through the addition method because I don't have a bunch of like terms. I want to solve by substitution and thoughts. Normally, yes, Brandon, normally I'd move the 7 over as a positive and I'd take the 2y plus 7, I'd plug it in for the x and I'd square it. But, there's a shortcut. What is 2y, class? What is 2y? X minus 7. It doesn't happen this way often, admittedly. Normally, you're going to have to do what Brandon said, right? Add the 7, square the whole thing, and solve all that stuff. But in this case, I could just put an x minus 7 in for the 2y, couldn't I? To get what? Yeah, x squared plus x minus 7 equals 5 instead of 2y. So if you see something like that, those are just shortcuts we can take if we see them. And once again, it's a quadratic though, right? A parabola and a straight line, you expect to intersect how many times? Twice, or maybe none at all, right? Probably twice though, right? So it's not surprising we get a quadratic here where if I have a quadratic, I want to set it equal to 0. So let's bring the 5 over as a negative to get x squared plus x minus 12 is equal to 0. Oh, I can see the backwards FOIL here really well, class.
Plus 4 negative.
Good, x plus the 4x minus the 3. There we go. And so I get two different x values, two abscissas. All right, so one of the points of intersection is it has an abscissa of -4. The other point of intersection, abscissa of 3. The only downside is that since I never got a letter by itself, the plug-in value is a little harder, but it's not that bad, and hey, it made it so easy. So let's plug in the -4. If I plug that in, I get, but I have to divide by 2, so -11 halves. If I plug in the 3 right here, what do I get? -4, and then divide it by the 2, -2. I'm not losing anybody. I'm hearing the same 2 people answering all the questions, so I'm glad they've got it. Do the rest of you got it? Keeping up okay? Just maybe not answering? All right, feel free to jump in. If we were to look at this graph, here's what you get. There's the line. There's the 2y equals x minus 7. By the way, notice the parabola is inverted. People watching on YouTube, just look back at your paper where you originally copied it. You realize you'd have to bring the x squared over as a negative x squared. Hence, it would invert your parabola if we were to graph the function there. And we see these points of intersection right here, nice and easy, 3, -2. And the next one's a little harder, but we've got it at -4, and then down 11 halves is 5.5. And we see that point there. Okay? Questions on that? All right, write this next one down. X minus 3y equals 2. X minus 3y equals 2. And xy plus y squared equals 20. Xy plus y squared equals 20. Top equation should be really easy to tell what we got.
Straight line.
Straight line, linear equation, yeah, no problem there. Second equation, anytime you see an xy, you know it's got that, that rational function look to it. So we're getting some kind of straight line and some kind of rational function-y thing here. So again, we're expecting to get 2 points of intersection from the line and this hyperbola. This one's especially ugly. Thoughts on what we might do to solve this one? So besides Audrey and Brandon, thank you two for participating so well, but thoughts from someone else? Okay, substitution. And which letter do we want to substitute for? Definitely the x. If you substitute for the y class, do you see there's 2 places you should have to plug it in? And of course, it'd be a nasty fraction. The x is easier, and there's only one of it. So this works great if we rewrite the top equation how, Genesis?
X equals positive 3y plus 2.
Yeah, 3y plus 2 or 2 plus 3y, either way, right? And then we're going to take this 3y plus 2 and we're going to plug it in where it says,
Where the x is.
yeah, where the x is. So my bottom equation now becomes 3y plus 2y plus y squared equals 20. What am I going to have to do with this y right here? Anyone? Distribute. There we go. So when we distribute, we get? Sure.
Oh, okay. 3y squared plus 2y.
There we go. And of course we can combine like terms here, Maddie. And let's also bring the 20 over as a all equal to 0. Of course, I don't want to solve it like this. I want to make my life a little easier. Michael?
Take out 2.
Yeah, knock out the 2 to get
2y
squared.
y equals 10.
Or minus 10
Yeah.
equals 0. And now comes the fun part of backwards foiling it, we hope. Because if not, it's either complete the square formula. 2y squared class would have to factor into
2y and y.
2y and y. All right, the negative sign. Positive, negative signs are different, right? And then 10, probably 5 and 2. Definitely not 2 and 5, remember. I can't put a 2 with another 2. But a 5 here and a 2 here. Let's see if that checks out. It does. Okay, so what are my two y values? Negative 5, 2s, and 2. All right, so I'm getting, as I said, I'm anticipating 2 points of intersection. I've got two different y values. I've got a y value of 2, and I've got a y value of negative 5 halves, or negative 2.5. How do I go about getting the abscissa, or the x value for each of these, Michael?
You plug them in.
Plug them in. So when I plug in the 2, I get?
Where are we? Okay, we're there. 8.
8. And the ugly ones, when I plug in the negative 5 halves, I get, what, anybody?
Negative 11 halves.
Negative 11 halves, somebody like that? Negative 5.5, negative 11 halves? Yeah, let's do that one, negative 11 halves, that looks good. All right, let's see what that looks like graphed. So there's, you can't see a whole lot because it's really stretched out, but you see that hyperbola forming there, and there's the straight line coming through. We got 8, 2 as one of our points, and then, let's see, here would be negative 4, negative 5, negative 5.5, or negative 11 halves, and then down 2.5, or negative 5 halves, and there's our 2 points of intersection. Wouldn't it be nice if graphs came on the test, you could check your answers, make sure they worked, but anyway, we have that now. Questions on this? Let's work a little bit more interesting problem now. Write this one down, if you would, please. X squared plus y squared equals 25. X squared plus y squared equals 25. And then 4x squared plus y squared equals 52. 4x squared plus y squared equals 52. What is this, this first shape going to be, class? You remember? You're not going to be testing a quiz on it, by the way. You don't have to memorize it, but this could be a circle, right? Perfect x squared plus y squared. Here we introduced a number on the x squared, 4x squared plus y squared. That's going to be the ellipse. How many places could a circle and an ellipse intersect?
A lot.
2, or possibly 1, possibly none, possibly 3. Well, let's see what we've got here. Okay, so if I had an ellipse, by the way, it's going to be squished in on the x because the number's in front of the x. And if I had a circle that was just the right size, right, I could get 2 points. Or if it were a little bit bigger on one side, this really feels like geometry, doesn't it? Those who've been through it. 1, 2, 3. Or maybe if the one falls inside the other like that, or even outside, we get 1 point. Or maybe it just fell all the way inside, and we got no points. Any other possibilities?
4.
Could it 4 times? Okay, so that would be, for instance, if the circle kind of came out around here, 1, 2, 3, 4. Could I ever get more than that? No, but you gotta admit, that's a lot of possibilities. Either 0, 1, 2, 3, or 4 possibilities present themselves. Let's see what the algebra tells us. Now, I want you to notice, we do have like terms lined up. It's just not xy equals number, it's x squared y squared equals number. So here we can use addition because they're both quadratic. Let's just put a negative through the top. Could you solve by substitution still, of course? Question?
Would it be safe to just say that x and y for the top one equals 5? Because on the previous problem that you showed us, x squared plus y squared equals 16.
The radius will be 5 of the circle. That's safe to say. So if you were graphing it, yeah, absolutely. You could say I got a 5 here, 5 here, 5 here, 5 here. That's true. This is 5 and 0, or 0 and 5, yes. But I mean, there's all kinds of points that are going to be along here, like this one here. That's not an x that's 5 or a y that's 5. They're both something different. Does that make sense?
Mm-hmm.
Yeah, good question, though. I like that you're thinking. And good observation as well. Yes, this will have a radius of 5. Let's put a negative through the top. What happens to my y squares? Cancel. That worked out well. Here, 3x squared is equal to 27. Let's divide away the 3, get x squared equals 9. And so incomplete quadratic, right? X is equal to... Good, not just 3, positive 3 and negative 3. 2 different x values, correct? Now here's where it gets interesting. Let's go back to the easy equation. The x squared plus y squared equals 25. Let's start by plugging in the 3. Class, if you square the 3, you get 9. Then subtract the 9 to get y squared equals 16. And then when you take the square root, we get y equals positive and negative 4. Now watch. I plugged in one number, 3, one abscissa, 3, but I got 2 y values. That already tells you don't have a function, right? But what that means is I've got a y value of 4, and for that same 3, I also have a negative 4. Do you see that? Now let's go through and let's plug in the negative 3. Well, if you square the negative 3, class, you get, you subtract the 9, you get 16. You take the square root, you get. So the negative 3 also gives me not just a 4, but also a negative 4. 1, 2, 3, 4 points of intersection. And here's your graph on this one. So there's your ellipse that's been squished in on the side. There's your circle, by the way, radius 5, as Michael noted. And they're at 3, 4, or 3, negative 4. 3, 4, negative 3, 4, and negative 3, negative 4 are your 4 points of intersection. Questions on that? Notice you could solve by the addition method because you had like terms. So something that's a little unique there. Questions on this problem? Let's do one more, and then we'll be done for today. One more. But you know, it's having fun looking at things we hadn't seen before, right? So kind of new stuff, always fun and exciting. Right, Brandon? You sound very enthusiastic, Brandon.
Yeah, it's fun.
Okay. Said it really faked. Alright, 3x plus y is equal to 12, and x squared plus y squared is equal to 9. Top equation, class? Straight line, right? It's linear. Abby, bottom equation.
Circle.
By the way, with what radius, Michael?
3.
3. All right, so no like terms this time, right? By the way, why can't I just square the top equation and get y squared so they cancel? Why can't I do that, class?
Wouldn't be accurate.
Because when you square, you don't square everything. You'd have to square both sides, remember? And square the first, square the last. The multiply and double is what would get you, right? With an xy term, hyperbole, we don't want that. Okay, so that's why we don't just square. Plus, we'd be creating additional points of intersection in the process. So we're going to solve it not by the addition method, but by substitution. Walk me through the substitution here, Genesis.
Change the top equation into y equals negative
Yeah, I don't like leading with the negative either, so I like that you flipped it for me and said 12 minus 3x. And of course, class, we're going to plug the 12 minus 3x in for the y right here. So Kendall, tell me how to write my bottom equation.
X squared plus the quantity 12 minus 3x squared equals 9.
All right, now tell me what to write down, Brandon.
X squared positive 144 negative 72 x positive 9x squared equals 9.
There we go. As we square the first square, the last multiplying double. Good job with that. Now what do we need to do, Maddie? Okay, move that 9 over. I put it right here with the 144 to set it equal to 0. Right here, that 144 negative 9? A positive 135. I'm going to put that at the end, okay? There we go. So we have the 10x squared as we combine the x squared and the 9x squared, then the negative 72x, then the positive 135. It might factor really well, but that's big, and I can't take anything out to make it smaller. Anyone want to try to factor it? Michael's like, yeah. Anyone just like, let's let the calculator do all the work? I'm a calculator do the work. Get your calculators ready. What is the quadratic formula again, class? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's say that again together just by way of review. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So what is a, what is b, what is c in this particular problem here? Michael?
10 is a, 72 is b. Yeah,
Negative 72 is b, there we go, and c?
135.
135. All right, so when it says negative b here, Abby, I need to plug in
72.
72. Plus or minus, and this is why the calculator is doing the work, 70, or negative 72 technically, squared, must be the same thing as 72 squared because we're squaring, but anyway, big number?
5,184.
5184, all right, minus, we need to take 4 times a times c. 5400. All over 2a, that's at least easy, class. 20. All right, of course, we need to combine the 5,184 minus the 5,400, class.
Negative 216.
Wait a second. Negative? I'm supposed to take the square root of a negative. What do we do when we have a square root of a negative, class? Pull out your eye. Wait a second. So this is at 72 plus or minus. I'm sure I could simplify more, but let's just stop here for a second. 72 plus or minus I square root of 216 all over 20. Remember, what we're solving for is x. We're solving for an abscissa right here, or two abscissas, right? Can you have imaginary or complex values on the Cartesian plane? No. So, if we end up with an imaginary value, if we end up pulling out the I, that just means that this line and this circle only actually intersect in an imaginary world. They're never going to intersect. Let's take a look at our graph here. And that's how you would know that a graph misses. How we know the line and the circle miss each other? It came out with an imaginary point of intersection, an imaginary abscissa. So we would just say no real points of intersection. No real points of intersection. And that will be our answer. For homework this evening, you're going to practice with 3 of these systems of quadratic equations. 3 systems of quadratics for homework. Page 229. Page 229, the practice 13 to 15. Now, it's going to say to graph them and solve. We ain't doing that, okay? We're going to do substitution. Okay, page 229, the practice 13 to 15. Also, on page 250, do number 15. On page 250, do number 15. That's a system of 3 unknowns. One more round with practice with that. Don't forget your exam is Friday, lesson 133, over sections 4.1 to 5.4. Tomorrow, we'll wrap up systems of equations. Wednesday, we're going to begin reviewing for the exam. Thursday, we'll continue and finish reviewing for the exam. Friday is your exam. Have a wonderful rest of your day, and you are dismissed.